20.4 more on quadratic equations. The discriminant. For a quadratic equation in the form of ax squared plus bx plus c equals 0, the expression b squared minus 4ac is known as the discriminant. It tells us the nature of the solutions of the equation. So remember that b squared minus 4ac, if that sounds familiar and you're not sure why, comes from the quadratic equation, the quadratic formula. That's x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So the discriminant is this part under the radical. So if under the radical you get 0, the square root of 0 is 0. So it would be negative b plus 0, negative b minus 0, which is the same thing. And so that's why it is only one solution. And there's only one x-intercept. So your solutions are your x-intercepts. If this part under the radical, your discriminant, is positive, then you get two real number solutions. And you have two different x-intercepts. And then if it's negative, remember anytime you have a negative under a radical, you get an imaginary number. So there are two different non-real complex number solutions. So meaning you'll have an I in there. So you can use the discriminant to tell you what kind of answer you'll be getting, what kind of solution you'll have, and how many, if you'll be getting one or two. So on your turn 1, determine the nature of the solutions of x squared minus 4x plus 4 equals 0. So a is 1, b is negative 4, c is 4. So the discriminant is b squared minus 4ac. So b is negative 4, so negative 4 squared is positive 16, minus 4 times 1 times 4 is 16, minus 4 times 1 is 4 times 4 is 16, which is 0. So it's going to be one solution, and it's going to be a real number. Example 2, determine the nature of the solutions of 2x squared minus 3x minus 4. So a is 2, b is negative 3, c is negative 4. So b squared is 9 minus 4 times a times c. And then negative 4 times 2 is negative 8 times 4 is sometimes negative 4. Negative 8 times negative 4 is positive 32, which is 41. So it's a positive number under the radical, so we're going to get two real solutions. Example 3, a is 3, b is negative 2, c is 8. So b squared is 4 minus 4 times a times c. 4 minus 4 times 3 is 12, times 8 is 96, negative 92. So since we're going to have a negative under the radical, we're going to have two complex solutions, or two non-real solutions. And your term 4, determine the nature of the solutions. So a is 4, b is 7, c is negative 2. So b squared minus 4 a c. Negative 4 times 4 is negative 16, times negative 2 is positive 32. And so this is going to give me two real solutions. Okay, writing equations from solutions. If we know the solutions of an equation, we can write the equation by using the principle of zero products in reverse. So instead of having an equation and finding the solutions, we're going to be working backwards. We're going to have the solutions and we're going to work backwards and find the equation. So here's an example. Find a quadratic equation for which 2 and negative 1 are solutions. So if 2 and negative 1 are solutions, that means that before I got 2 and negative 1, we're thinking factoring. We factored it and we got x minus 2 times x plus 1 equals 0. So that when I set x minus 2 equal to 0, I got x equals 2. When I set x plus 1 equal to 0, I got x equals negative 1. So now to find my quadratic equation, I'm just going to use FOIL and get it in the form of ax squared plus bx plus c equals 0. So first times first, x squared, and then outside, inside, last times last, and then simplify it. So x squared minus x minus 2 equals 0. Alright, so your turn 1, find a quadratic equation whose solutions are 3 and negative 1/2. So I'm going to start out with my factored form. So it would be x minus 3 and x plus 1/2 equals 0. Because if I have x minus 3 equals 0, then solving for x gives me x equals 3. And x plus 1/2 equals 0 gives me x equals negative 1/2. So then we'll just use FOIL to multiply those out. So x times x is x squared. And then my plus 1/2 x minus 3x minus 3 times 1/2, that's the same thing as 3 over 1, so multiply straight across, 3/2 equals 0. And then I can clear the fraction by multiplying everything by the common denominator. So distributing the 2 to everything gives me 2x squared plus x minus 6x minus 3 equals 0. So I did that before I tried to add my 1/2 x minus 3x, because then I don't have to find a common denominator and all that. I've cleared the fraction and made them whole numbers. And so this is easier for me to combine like terms from that step. So 2x squared minus 5x minus 3 equals 0. Your turn 2, find a quadratic equation whose solutions are 4 square root of 5 and negative 4 square root of 5. So x minus 4 square root of 5, x plus 4 square root of 5 equals 0. So again, multiplying using FOIL, x times x is x squared, and then the outside plus 4x square root of 5. So notice the x is on the outside and the 4 is on the outside. So I'm multiplying those two together. So the 4x is on the outside and the square root of 5. The 5 is the only thing still under the radical. Same thing for inside, negative 4x square root of 5. And then last times last, 4 square root of 5 times 4 square root of 5. 4 times 4 is 16. And the square root of 5 times the square root of 5 is 5. So 16 times 5 is 80. So combining like terms, these actually cancel, and I have x squared minus 80 equals 0. Example 3, find an equation whose solutions are 9i and negative 9i. So x minus 9i times x plus 9i equals 0. So again, using FOIL, x times x is x squared plus 9xi minus 9xi minus 81i squared. Remember, I squared is negative 1. So 9xi minus 9xi cancels, so x squared, and then negative 81 times negative 1 is positive 81. So x squared plus 81 equals 0. Equations in quadratic form. Equations are quadratic in form or reducible to quadratic if, after an appropriate substitution, the resulting equation is quadratic. So, for example, y to the fourth minus 4y squared plus 3 equals 0 is quadratic in form because if we let u equals y squared, then the equation becomes u squared minus 4u plus 3 equals 0. So, looking at it, it's not raised to the second power, so it doesn't look like it's quadratic. It's not a quadratic equation, but it's in quadratic form because we can replace the y to the fourth as a y squared, and then a y squared with a u squared, and then the y squared with a u, and put it in quadratic form. X plus 2 squared plus 3 times x plus 2 minus 28 equals 0 is in quadratic form because we can let u equal x plus 2, so then it's u squared plus 3u minus 28 equals 0. And then the third example, x minus 2 square root of x plus 1 equals 0 is in quadratic form because we can let u equal the square root of x, so that makes x u squared minus 2u plus 1 equals 0. Alright, so looking through the examples, your turn 1. Solve y to the fourth minus 6y squared plus 8 equals 0. Well, in order to solve it, I need to put it in quadratic form. So instead of y to the fourth, I'm going to write it as u squared minus 6u plus 8 equals 0. Because if I have it in this form, then I can factor it. So u squared is u times u, and I'm looking for two numbers that multiply to make 8 and add to negative 6. So 4 times 2 is 8, and negative 2 and negative 4 is negative 6. So then setting each of these equal to 0, u minus 4 equals 0, u minus 2 equals 0. So u equals 4 and u equals 2. But remember, my original equation is not in the form, is not in u squared minus 6u plus 8. It's y to the fourth minus 6y squared plus 8 equals 0. So what I need to do next is, since u was equal to y squared, we're going to say 4 equals y squared, and then solve for y. So take the square root, so y equals plus or minus 2, and then the same thing over here, 2 equals y squared, so y equals plus or minus the square root of 2. So I need to go back and check those to make sure that those solutions work. So I'm going to check positive 2 first. So going back to my original, so 2 to the fourth minus 6 times 2 squared plus 8 equals 0. So 2 to the fourth, 2, 4, 8, 16, minus 2 squared is 4, 6 times 4 is 24. 16 minus 24 is negative 8 plus 8 equals 0. 0 equals 0. So positive 2 is a solution. Next I'll check negative 2. So negative 2 to the fourth minus 6 times negative 2 squared plus 8 equals 0. This one's going to work the same way because when I squared a positive and fourthed a positive, I got a positive. This one I'm doing the same thing. Negative 2 to the fourth is going to be positive 16 minus negative 2 squared is 4. Negative 6 times 4 is negative 24. So negative 2 is also a solution. And then I'm going to check positive square root of 2 and negative square root of 2. So positive square root of 2, square root of 2 to the 4th minus 6 square root of 2 squared plus 8 equals 0. So the square root of 2 times the square root of 2 is 2 times the square root of 2 times the square root of 2. So it's like 2 times 2 is 4 minus the square root of 2 squared is 2. 6 times 2 is 12. So 4 minus 12 is negative 8. And negative 8 plus 8 is 0. So the square root of 2 works, and then the negative square root of 2 is going to come out the same way, because when I fourth it or I square it, it's going to come out to the same number and still positive. So all 4 of those solutions work. Example 2, x plus 3 square root of x minus 4 equals 0. So I want u to equal the square root of x. That means that u squared is equal to x. So here, in place of x, I'm going to write u squared, and in place of 3 square root of x, it's going to be 3u minus 4 equals 0. So when I replace that, I now have a quadratic equation that I can factor. So u squared is u times u, and two numbers that multiply to negative 4 and add to 3 are 1 times 4. So 4 minus 1 is 3. U minus 1 equals 0. U plus 4 equals 0. So u equals 1 and u equals negative 4. Now we have to go back to our original substitution. U squared equals x, or u equals the square root of x. So 1 equals the square root of x. So square both sides. X equals 1. And then negative 4 equals the square root of x. So square both sides. Negative 4 squared is positive 16 equals x. So x is equal to 1 and x is equal to 16. We need to go back and check it. So we'll check this one first. So back to the original. 1 plus 3 square root of 1 minus 4 equals 0. So 1 plus 3 times the square root of 1 is just 3 times 1, which is 3. 1 plus 3 is 4. 4 minus 4 is 0. So 1 is a solution. And then next we're going to check 16. So plugging that back into the original. 16 minus 3 square root of 16 minus 4 equals 0. So 16 minus, the square root of 16 is 4, so 3 times 4 is 12. 16 minus 12 is 4. 4 minus 4 is 0. So both 1 and 16 are solutions. Example 3, 4x to the negative 2 minus 8x to the negative 1 plus 3 equals 0. So for this one, we're going to let u equal x to the negative 1. So u squared is x to the negative 2. So I'm going to rewrite this as 4u squared minus 8u plus 3 equals 0. So I can factor this. So this one has a coefficient in front of the squared term, so I need to factor it by grouping. So 4 times 3 is 12. My middle term is negative 8. So I'm looking for two numbers that multiply to make 12 and add to make negative 8. So 6 times 2 is 12, negative 6, and negative 2 is negative 8. So this is going to be 4u squared minus 6u minus 2u plus 3 equals 0. So 4u squared minus 6u have 2u in common, leaving me with 2u minus 3. And then negative 1 2u minus 3. So this is going to factor to 2u minus 3 times 2u minus 1. So setting each of these equal to 0, gives me u equals 3/2 and u equals 1/2. Alright, so now we're just going to plug it back in to find what x is equal to, now that I know what u is equal to. So remember that u is equal to x to the negative 1, so that means x to the negative 1 is equal to 3/2. So x to the negative 1 is the same thing as 1 over x. So then to solve for x, since it's a denominator, I'm going to multiply both sides by x. I can actually multiply by 2x, so I multiply by the common denominator and clear all the fractions. So this would give me 2 equals 3x divided by 3. X equals 2/3. And then do the same thing for the 1/2. So x to the negative 1 equals 1/2. So 1 over x equals 1/2. So clear the fractions, times 2x times 2x. 2 equals x. So x is equal to 2 and x equal to 2/3. Okay, and example 4, find the x-intercepts of the graph of f of x equals 3x minus 4 squared minus 3 times 3x minus 4 plus 2. So in this case, u is going to be equal to the 3x minus 4. So I can rewrite this as u squared minus 3u plus 2, and then equals 0 because we want the x-intercept, so that's when y is 0. So we'll factor this. U times u, 1 times 2, negative 2 and negative 1 gives you negative 3. Set each of these equal to 0. So u equals 1 and u equals 2. So now plug it back into this. So 3x minus 4 equals u, which is 1. And then 3x minus 4 equals 2. So solving for x equals 5/3. And x equals 2.